Assalamu alaikum students and welcome to another lecture of Slate. This is Sir Yasin. Let's study chemistry. In A-levels chemistry, the concept of moles is as similar to as that of O-levels. But obviously the difficulty level has increased without any doubt. We see more questions, lengthier questions with more molar ratios, and that we've discussed in the previous lectures. But now, this concept of combustion analysis, it will again use the same concepts of moles. Same molar ratios, same formulas. But this is how, with this idea, with this concept, with the combustion analysis, we can calculate the formula of unknown hydrocarbon or an unknown organic compound. So combustion analysis, if you remember, when we burn a hydrocarbon, or an organic compound with C, H, and O is burned or is combusted or is burned in the presence of air or oxygen, what do we get? Just two products, carbon dioxide and water. And if you recall, we could easily balance the equation. The products were same. Like for instance, if we had let's say propane. We know we have carbon dioxide and water as products, and we used to balance it this way. 3 carbons, 4, and then we are left with 5 oxygens. So we used to balance the equation this way. But in combustion analysis, we get carbon dioxide and water, we get their masses by using different absorbents like potassium hydroxide and magnesium. But what happens here? We get the masses of carbon dioxide and water produced. And with the help of those masses, we can easily calculate what our organic compound is. But before we jump to a past paper question, there is an equation to understand which we call finding formula of a hydrocarbon. Where CXHY, both carbon and hydrogen are known, the number are unknown. They are burned in oxygen, that we know. We get carbon dioxide and water. Even that is something that we know of. But what about the balancing? We remember one thing with this equation, look at here. If we have X number of carbons, we have X moles of carbon dioxide. If we have Y number of hydrogens, we have Y divided by 2, half moles of water. And then X plus Y divided by 4 moles of oxygen. Like we know 3 plus Y, which is 8 divided by 4, 2 moles, which is 5. So this is the finding formula for hydrocarbon. But now, with this formula, we can understand that the relationship of carbon dioxide with the hydrocarbon and water with the hydrocarbon. So let's jump to a question. We'll just discuss 2 different questions, and that would give a lot of clarity on the concept. Upon combustion, a hydrocarbon produces 25.15 gram of carbon dioxide, 11.58 gram of water, and the molar mass of hydrocarbon is this. Find the empirical formula and the molecular formula of hydrocarbon. Now, we need 2 concepts, molar ratios and then empirical and molecular formula calculation. So first of all, whenever you see a mass in chemistry, you take the moles. So we calculate the moles of carbon dioxide, mass over mR. Mass is 25.15, mR is 44, equals to, let's see, and we need the moles of water as well. Again, 11.58 divided by the mR, which is 18. Let's calculate the values. What do we get here? This one is 0.5716. And the other value, .6433. Because we are following four significant figures because of this very value. We follow the significant figures from the question. Now, we need to make two different ratios. Ratio of carbon dioxide and carbon. What do we got from this equation? They have the equal ratio. So always, the number of moles of carbon dioxide equals to the number of moles of carbon. Hence, the number of moles of carbon are 0.5716. If you make a ratio of water and hydrogen, so if we have 8 hydrogens, we have 4 waters. So 2:1. So 2:1. Now, water's moles are 0.6433. We multiply the value by 2 and we get 1.286. These are moles of water. Now we have the moles of hydrogen. Now we have the moles of hydrogen, we have the moles of carbon. Now we can easily make a ratio between carbon and hydrogen. Similarly, it's similar to what we do in empirical formula calculations. Like carbon ratio, hydrogen. So 0.5716 ratio 1.286. These are the moles. What do? We divide by the smallest value. Which one is the smaller value? 0.5716. This gets a value of 2.25, while this gets a value of 1. Now students, we were supposed to get a whole number here as well. But now that we haven't received the whole number value, we're going to multiply this with another whole number to make it whole again. Let's say we multiply this by 2. This will be 2. This will be 4.5. That is wrong. If we multiply this by 3, this will be 3. This will be 6.75. Again, not a whole number. If we multiply this value by 4, we get 4:9. Now we've got a whole number value, and this is completely right. So if this is the final whole number ratio that I have, so what will be the empirical formula? C4H9. Now, how do we calculate molecular formula from empirical formula? We have discussed that many times. So molecular formula equals to N into empirical formula. N is the number, we need to calculate that. While empirical formula is C4H9. How to calculate N? N into MR divided by empirical formula mass. MR is given. Molar mass, MR, it's same thing, 114. While we are going to divide it with the mass of empirical formula. So what is that? Let's calculate. 12 into 4, plus 9. That's 48 plus 9 equals to 57. So if I divide 114 by 57, the answer is 2. And the final formula will be 2 into this. Hence, molecular formula is C8H18. That is octane. So this is how we calculate. Now in this question, students, we got only two things. We only got hydrogen and carbon. But let's say in another question, we have oxygen as well. It will get a little lengthier, but still it's basic. Let us assume that a compound containing carbon, hydrogen, and oxygen was burned in combustion analysis apparatus. 2.714 gram of sample yielded this amount of water and this amount of carbon dioxide. So what shall be the steps? The same ones. First, we calculate the moles of carbon dioxide, mass over MR, divided by 44, which is the amount of carbon dioxide, and moles of water So let's calculate the values. This is 0.1070. Again, 4 decimal points because we've got that there as well. Here we have 1.928 divided by 18. This is more or less the same value. Now, we need to calculate the moles of carbon and hydrogen separately. For carbon, we know moles of carbon dioxide equals to the moles of carbon. Hence, 0.1070. But when we talk about the moles of water, this is 2:1. And if the moles of water are 0.1071, this will be moles of hydrogen are 0.2142. Now what to do next? We have the mass of the whole compound, but we cannot calculate the moles of the compound because we don't know its formula. We don't know how many oxygens can there be. So what do? We have the moles of both carbon and hydrogen. We need to know the amount of oxygen first in order to be able to calculate the mass. We cannot calculate the moles of oxygen, but we can still calculate the mass of oxygen if we subtract the mass of hydrogen and oxygen from the whole compound. So we need to convert these value of moles into masses. For example, mass of carbon in the compound will be, we convert the formula mass over MR into mass equals to mole into MR. So for carbon, we have the moles 0.107 into 12. And for hydrogen, that's very basic. This value into 1 because that's the amount of hydrogen. So the mass of hydrogen is 2142 grams, while the mass of carbon is 1.284 grams. Now this is the mass of carbon. Now what shall we do after this? We have the mass of complete compound, which is 2.0714. Mass of compound equals to mass of carbon plus mass of hydrogen plus mass of oxygen. So obviously we're going to subtract the mass of carbon and hydrogen from the compound. And the final value will be the mass of oxygen. The final answer is 0.5732 grams of oxygen. Now, in order to find the empirical formula, we need to calculate the moles of oxygen as well. That's simple. Mass over molar mass. So, 0.5732 divided by 16, which is the mass of oxygen atom. And the answer is 0.3582 moles. Now we have the moles of carbon, we have the moles of oxygen, we have the moles of hydrogen. We'll just make the molar ratio between all the values: carbon, hydrogen, oxygen. The mass of carbon is, moles. We have the moles here. The moles of hydrogen are while the moles of oxygen were, there is one extra decimal that I added, 0.03582. So obviously we divide all the values with the smallest value, which is that of oxygen. We know oxygen gets one ratio. Then let's calculate the value of other ratios. Again, this is this is 3 and this is 6. So now we have the empirical formula C3H6O1. So how to calculate the molecular formula? Same formula. Molecular formula equals to N into empirical formula. Empirical formula is given to us. N we need to calculate. We have the mass. Where do we have the mass? 116.16. Divided by, what is the mass of this whole compound? 12 into 3 plus 6 plus 16. 36 plus 6 is 42. 42 plus 16 is 58. So again the answer is 2. We multiply this by 2 and the final formula is C6H12O2. So students, these were very basic calculations of moles in combustion analysis. We can easily see if we have a hydrocarbon, that's a very basic question. But if we have another element, even sulfur can be there. Thiosulfides are there. But we do this the same way. So thank you so much for being here with me. This was all regarding moles. Take care and Allah Hafiz.